All right. So you do need a computer today. So please go ahead and get one out. The goal here today would be that we are at least working on or maybe finishing our homework before we walk out of here today. Um, we are looking at two main ideas today inside of this section of what are called distributions of data. When we distribute that data, what we're really saying is how can we represent it? How can we show it? We're going to use Desmos today to aid us in this, I guess, in this technique, bless you, that you probably have already done by hand before, though maybe we just don't remember exactly how to do it. So we are looking at histograms and box and whisker plots. Okay. Now, I would think at least by picture, you could tell me what those are. Okay. But what do you know about them? What do you know? And which one are you talking about? Okay.
Don't you have like the box and then it's separated into like three different parts and then like the lines that say like and then like the middle is like the
Okay. All right. So in a box and whisker plot, there is some box in the middle. There is a line that separates it, and then there,
there's a line at the end.
yeah, the quote whiskers, right? We got something that looks like this. Okay. What are we getting from that?
Don't you get like a 5-sum summary?
Okay. Yeah, so it's called a 5-number summary. All right. Because truly a box and whisker plot is made up of 5 numbers. All right. Obviously, these 2 dots at the end are make 2 of them. Number 3, number 4, and number 5. What are those 5 numbers, though?
The middle line
Yep.
is
Is not the mean, the median. All right. So the middle value, the median. Okay. What else? What you got? Okay. So on the left-hand side, we have the minimum value. On the right-hand side, we have the maximum value.
the second line.
This one here.
Yeah.
Yep.
Is the inner quartile range?
So it is a part of the inner quartile. Yep. And we would call this one the first quartile or Q1. And then over here on the right-hand side, Q3. All right. Essentially what we're saying is the first quarter and the third quarter. All right. The median is truly the second quarter. Okay. So what we're getting here is we're getting a distribution of our information broken up into 25% chunks along the way. Okay. All box and whisker plots have to be on a number line. Okay. We don't get to choose what these sections are going to look like. They're going to be plotted on some number line, and that will show the spacing along the way. We don't get to make that decision of what that's going to look like. You did mention something else, the inner quartile range. What is that?
Isn't it the whole box?
Not, yes, the whole box. Good. So it is Q3 minus Q1. It's that middle 50%. Okay. Is that what you were going to say? All right. So the range would be from the max to the min, but the inner quartile range would be from Q3 to Q1. Okay, so that's some information about a box and whisker plot. What about a histogram? Yeah. Do you need to see just a generic picture of one? Okay. So may look something like this on a graph here. Maybe it looks like this. Oh yeah, yeah. I don't know, something like that. Whatever. What is that? Yeah, don't say histogram. I know. What is it doing? Go ahead. What do you think?
Different like sections of something and show like the amount. I don't know.
Okay. What did you say? A bar graph? For a long portion of my career as a student, I thought that a bar graph and a histogram were like the same thing. You just smashed one together. I didn't really like, is there really a difference? They are, right? So why are in a bar graph, why are they separated? Why in a histogram are they together? That's got to be telling me something. Say that again. In which one? In this one? Okay.
Because like in a histogram they're kind of connected, but on bar graph they might not use like necessarily like favorite color or class like it.
Okay.
They're not like together in any way.
All right. So yeah, in a bar graph, you're talking about a comparison of categories. How many people like the Browns? How many people like the Steelers? How many people like the Chiefs? How many people like the Seahawks? Who you like? The Panthers. Ouch. One. All right. So, that's a bar graph. Those sports teams did not have any connection to each other than the fact that they were in the same league. But when we talk about a histogram, we may talk about, like how many people have been on vacation in their life between 0 and 3 times? How many have been on vacation in their life between 4 and 6 times? How many between, you know, 7 and 9? How many between 10 and 12? Do you know what I'm saying? That is a histogram. When we talk about having intervals down here and how many fall into those intervals, and they're connected because they're all talking about how many times we have done something, and whatever it is, it's that same something versus who likes this team or who likes that team, so on and so forth. Okay. Now, when we graph these, and like I said, we're going to do it inside of Desmos today, what we have to look at here is how does my graph produce? What's the picture look like? Okay. And so these distributions can come out in one of two ways. They can be symmetric, like the middle picture there, where it's kind of got that even. We saw a picture look very similar to this yesterday, talking about standard deviation, that bell curve, kind of having that even flow on both sides. Or it can be skewed or essentially pushed from one side to the other. All right. Now, just because this first one says it's negatively skewed, when you hear the word negative, you automatically, I would assume, think it to be bad, right? Like there's some kind of issue. But if you were looking at a score like this and we were talking about test scores, we would want it to be negatively skewed. Why? We would want that to be the case. Okay, there definitely is improvement. Sure. I mean, if this is on a number line, the x-axis is simply a number line, better scores would be further down to the right, would they not? If it was positively skewed, like this one over here, and we were talking about test scores, what's that mean? Oh, I guess we're doing a whole reteach there, huh? We got some issues going on, right? I mean, if all of my scores or the majority of my scores are over here on the left-hand side, what's that say? No bueno, we got some work to do. All right. We obviously missed the boat. So based off the way the picture looks, kind of can tell me some information about it as well. Now, we are going to use our calculator, our Desmos calculator, to do this one here, okay? So it says the average wait time in seconds of 33 sampled visits to the McDonald's drive-through before an employee took their order. So, like, how long did you sit at that box before somebody, popped on and said, welcome to McDonald's, what can I get for you? Like one of those kind of moves, right? You're like, I'm sorry, what? Okay. Now, just like we have in the past 2 days, if we're going to get this information into Desmos, we are going to have to open a table. So if you have not, and I did see some of you guys already did, you hit that plus button and you opened a table, and you're going to need to input those numbers in there. Okay. There should be 33 of them. Well, there's like 3 restaurants here in town, so. Oh, for real? That's big news right there, boys and girls. Taco Bell coming to the Fulton.
Actually,
33, I think. Yep. Okay, so once you get them all in, do you guys have them all in yet? Yeah. I don't want to lose you, so hurry up and get up there so you can see those and get them in.
Can we just sit here? No.
Nobody.
Everybody's sleeping.
She only focuses on what's in front. That's good.
Yeah, I don't really care about doing that much.
Whoa. No reason to get aggressive. Quinn, how many more you got before you get them in there? All right. So for the rest of you guys, as we are getting there, you're going to want to go ahead and click in the second equation bar there. We're going to input something there. I heard some of you guys talking about pulling up your keyboard and going over to function, but in this particular case, we actually don't need to go over there. We can actually call on the graph that we want. And so the questions there says that we are going to construct a histogram. So you're literally going to type the word, Quinn, you got them all in? Yep. So you are going to type the word histogram into the box. And then go ahead and hit shift, open a set of parentheses, and whatever your table was labeled, probably was labeled X1. And then go ahead and close it. All right. And you should, if you come over to your graph, you might have to zoom out a little bit. You're going to get a histogram. Now, couple things so we're all on the same page here. Number one, when you do this, it is always going to give you a histogram with interval widths of 1. All right. And we're actually going to change that a little bit so that our groupings are a little bit wider. Okay. If you go back inside your parentheses, okay, so right next to the X1 there, make sure that you're not on the subscript level, that you're up on like the level of the word histogram and the X. Are you all with me on that? Put a comma in there. Your graph will go away for a second. But the moment you put a number in there, what you're basically telling the graph to do is to count in a different interval. So like, for example, if I put a 3 in there, it's going to count all my intervals by widths of 3. Okay. I could take the 3 out, make it a 5. So now all my groupings are counting by 5s. Oh, yeah. If you made it 100, you're going to have 1 bar. Okay. Now, here's the other thing that I would suggest that you do. Every one of these sections is called a bin. And essentially, you could think of a bin as like a place to hold. And that's all that's happening here. It's telling us how many values that it's holding. Okay. Right now, it's probably, I would assume on your screen, it's on the center. But if you click on the button that says to the left, it will basically force everything to go starting at 0. So now it's counting 0 to 5, 5 to 10, 10 to 15, so on and so forth. Well, if we go back to our picture for a second, yeah, which one of these right now does it look like? A negatively skewed, all right? Which actually in this problem is a little bit problematic. If you think about this, remember, this is the wait time that people are sitting at the drive-through. So what is it telling us right now about people at the drive-through? Yeah, they're sitting there longer than they're not sitting there, essentially, before somebody talks to them to place their order. We would definitely want to see this skewed in the other direction, saying that when you pull up to the window, we're ready to start talking to you. You know what I mean? What's up?
So even though it says like the negative, does it depend on the scenario?
Absolutely. Well, it'll still be called that, but yeah, you got it. So in this case, negative would actually be the way you'd want to think about this. Like that is a negative situation. That is not good. You know what I mean? In a second, we're going to see one about your chapter 9 tests, and they're all in there together. Okay. We would want it to look like this, where my bigger values are down to the right, right? Because that's going to imply that my grades are higher than they are elsewhere. Okay. Is everybody able to manipulate their picture like so that it basically looks the way the mine looks right now? You are not. Okay. Aiden, were you able to change Over here on the bin width, you were able to make that a 5. And then you also changed your alignment to be left aligned. Was that the difference? Okay. It's always going to be on center alignment, but I would suggest you make it left aligned. Okay. All right. What I would like you to do now is ditch what you see. And I'd like you to do it for this one here. And then I'll ask you a couple questions about your information here in a moment. So I'll give you a second to scrap what you got and put these numbers in. Yeah, I would not delete them individually. I would just hit the X and get rid of everything. These are percentages, by the way, that you're putting in here. This is from chapter 9. How many of you guys have your values in at this point? Okay. So once you get them in, I'd like you to do a couple things. One, I would ask that you change your bin alignment to left align, and you'll see why here in a second. And then secondly, I'd also ask you to change your bin width. I'll let you decide what you think you should change it to in this particular problem. What would make the most sense considering the information that we have in front of us? Probably should change it to 10s. Why?
Going up, well, not going up by 10. This just makes more sense.
Yeah, but why?
Because the grading.
Because it's a grading scale. And we're talking about grades, and grades are on a scale of a 10-point scale. So it would make sense that if we switch over here, that my grades should be counting in groups of 10. So that when I ask you questions about how many people got a C or better, how many people got a C or better? Zoom in on this a little bit. Like, you know what I mean? Like 70 or better, right? That's a C. You might have to zoom in a little bit on your graph. Some of your guys' graphs are so small, I don't know how you could see them. Remember, once you have your information in here on the left-hand side, if you don't want to see, you can just hit the double arrow, get that out of the way. So now you can see your information better. Okay. How many people got a C or better? Come on there, Quinn. Where did it go? Oh my goodness. Bring this over to the middle. And then there you go. Zoom in the middle. All right. What's up? What is it? You think 18? Well, how many people got a C? My bar says 5. Yours says 4? Oh, geez. Are you trying to tell me that I might have put one in wrong? Oh.
I have the number.
What's up? 14? 40 people? I don't think 40 people. What? You look like you got to go to the bathroom. You all right? 13? Well, I got 5 here. I got 3. That's 8. 9, 10. And that looks like another 8. So what I'm seeing is 18 on my screen.
I got 18 foot. Mine says they're 4 between 78 and 9 between 90 and
It says you have 4 here and what?
9
Over here? What do you got here?
3.
And how many here?
2.
So you have one more here and one less here that I mistakenly,
Yes, that's what I got.
I don't even know what it would be. Huh? 70's a C, right? Okay. Well, I guess I should probably go back through and see where I made my mistake. Or maybe you made the mistake. Yeah, that's what I'm saying. Chances are I'm right. Which one? Does yours look like mine? All right, then. What? Down there? A 65, I think.
It's like a 73.
Yeah?
You have a 73
Yeah,
somewhere.
after 93.
You trying to tell me there's no 73?
There's no 73.
There's a 93? Well, here's the nice thing, though, about I mean, if that is my mistake, and I ditch the 73 for a 93, I mean, it immediately is going to change my picture over there. So if that was my mistake, my 70 column drops by 1, my 90 to 100 column increases by 1.
You made that mistake on purpose so you could show us
I
how.
probably did not, but I'll take it. Thank you very much. Thanks, Kylie. All right. Now, histograms and then also the 5-number summary or a box and whisker plot. According to Desmos, they call it a box plot. So if we scroll down over here on our left-hand side and we click in the next equation box to type in one word, if we type in the word box plot, and then we open a set of parentheses, and whatever your table is, mine is still X1 because I deleted my other one.
Oh, that's cool.
All right, you will get that graph. Now, because I have them both on there at the same time, I can actually use this offset right here. If I change that offset to like a 5, it just simply moves my graph up 5 units. Here's why you would want to do this. If you have multiple ones going on at the same time, you can simply raise one up in the air so that you can get them on there, and be able to look at them at the same. So for example, if I change that offset from a 5 to a 10, it's going to move it up 10 units and get it out of the way of the histogram that's underneath it. Does that make sense?
Yeah.
And then you can also change the height. So like the height is going to be how big your box is in the middle. So it was at 1, but if I change it to a 3, it just gives it a little bit more width to it so I can see it a little bit better. All right. Now, just like the histogram, if we come back here, we also have distribution pictures for box and whisker plots. And the way a box and whisker plot works is it's all by percentages. So each one of these sections of the box and whisker plot represents 25% of my graph. But when I look at the symmetry here, if more of my 50%, notice here, is to the left, that's negatively skewed. If it's pretty much even, it's symmetric, or we would kind of consider it to be like neutral, like says the median is in the middle there. And then if the right-hand side, the right side is longer than the left, then that's considered to be positively skewed. So if I come back here or you look at your picture, which one of these 3 does that box and whisker plot match? It matches a negative, right? And it should, because the histogram also represented the same idea, okay? So I just wanted you to be aware of how I can use these 2 graphs inside of this program, okay? And so that's all you're going to practice today. There's a couple of them, and we have almost 20 minutes. They really should be able to do this, all right? Now, you're going to have to create something, whether it be a box and whisker plot or whether it's a histogram. The question will tell you that. But then you need to transfer your information over. So you're going to make your picture on your homework paper. Does that make sense?
Yeah.
It's got to have a number line underneath it. Okay? You can't just make your box and whisker plot wherever you want. So if I'm using this one that I see up here in green right now, I'm probably going to go from 50 to 110 and then mark them off everywhere along the way so I know where to put my information. Okay? All right. Any questions on that? Okay. Tomorrow we're going to review for your quiz. I won't see you guys on Monday unless you guys just want to come hang out. No takers? Okay, good. And then your quiz will be on Tuesday.